to introduce the idea of mole ratios and be able to write mole ratios. So first things first, what exactly is stoichiometry? Nice long word for math with moles and equations of the chemical variety. There are two types: composition stoichiometry and reaction stoichiometry. The first is going to deal with mass relationships. Specifically of elements and compounds. We've done a little bit of composition stoichiometry up till now. Reaction stoichiometry is going to involve mass relationships.
Did you guys have that person in geometry who were taking like quiz?
Yeah, she uses that.
Yes.
Mass relationships between reactants and products in a chemical equation. This is chapter 9. Yes?
What's before reactants?
Between? BTW? Between? Good question. I like to abbreviate. From there are four types of reaction stoichiometry. Again, we've done a lot of composition stoichiometry so far. A lot of stuff like what is the percentage of a compound that is carbon? What is the percentage of the overall compound that is whatever element? That's more composition based. We're going to focus on the four types of stoichiometry. There are four types of reactions I may give you for the most part, and we're going to work in this chapter on understanding all of them. The very first and simplest type is going to be where we go from moles to moles. For these, you need a mole ratio. The very simplest type of reaction stoichiometry starts with us just converting a quantity in moles to a quantity in moles. Types 2 and 3 are similar, they're just kind of in reverse. So in type 2, our given is moles, our unknown is grams. In this particular type, we're going to start with moles of a known. We're going to go to moles of the unknown. And then we're going to go to grams of the unknown. For this, you need a molar mass. For this, you still need a mole ratio. Type 3 is the reverse, where we start with grams, and our unknown is moles. we go from grams to moles of the known. Then we go to moles, the unknown. Okay. And our final type, put it all together. Start with grams, we end with grams. And this is what is typically referred to as stoichiometry. All of it is stoichiometry. This is the process. The longest of the processes. Nanomolar mass, mole ratio, molar mass. Okay, and again, we're going to focus all of our efforts in Chapter 9 on this particular understanding in how to go from moles to grams, or grams to moles, or grams to grams, just given pieces of information like a balanced equation. All of the reaction stoichiometry we will do require a balanced chemical equation. The major topic in section 1, the major goal, if you will, is to get you comfortable writing what we call mole ratios. Now, you've seen conversion factors before. You can write conversion factors of things like molar masses, and we're going to remind ourselves how to do that. But the new stuff is taking a balanced chemical equation and writing a mole ratio from that balanced chemical equation. And that's really the only thing, aside from just like, what is stoichiometry, that was in section 1. Can I erase? Yeah? Who needs a board? I know 4. Braden still needs, you need 4?
And then the bottom.
Okay. Talk mole ratios. They are defined as a conversion factor These are going to be conversion factors that are going to relate amounts of reactants and products in molar amounts using our balanced chemical equations. So we're going to start with a balanced chemical equation. Well, I'm going to give you an equation and tell you to balance it. Remember that your first step for all problems moving forward is to balance or check that the equation is already balanced. Do not take for granted numbers that may already be present in your equations in front of your compounds. It may only be half balanced, it may be balanced incorrectly. So you should always be checking for a balanced equation before we start. When it comes to stoichiometry, we're going to do this in a very stepwise fashion. So you need to get used to balancing and then writing mole fractions, which are these things that we're about to talk about. They're referred to as mole ratios by your book. They're also commonly referred to as mole fractions, mole amounts, molar relations, you name it. Okay? So our step 2 is going to be to write all mole ratios. Okay? And in this particular case, before I do so, what's my balanced equation going to look like? 2, 3. Okay? Mole ratios are going to combine 2 substances into a fraction. So we're going to pick any 2 substances and relate them together. I am first going to write my relationships for the reactant to each product. So the first one I can write, again, you're going to start with the number in front. Of each individual reactant or product when you're trying to write those fractions. Now, since it's a conversion factor, what else can I write? I can write the inverse, right? Don't drop your substances at the end of these. Okay? Now let's write another one. Our goal is to write all possible. So the second one I'm going to write is 2 moles of Al2O3 over 3 moles of O2. I'm also going to write the inverse. Braden, can I erase this now? Okay. And our last one, you still have to write it, you have to write all possible fractions. The last one is going to relate the 2 products together. To give you an idea of where we're going with this, these are the types of questions we're going to be working on. How many grams of something is produced if we start with grams of something else? And we're working on that middle step in all of those different types that you just talked about where it said need a mole ratio. Because we already know how to calculate molar masses. Okay? And eventually what we're working towards is what we call unit analysis. So we're going to set this up so that things cancel and leave behind only what we want. Okay? Make sense? Kind of, sort of? When you did your reading, was this confusing? Hopefully not so much. Just because once you look at a balanced equation, you should see where the numbers are coming from. Does this make sense? Okay. All right, so I'm going to put a couple of equations on the board. I want you to balance and write mole ratios, and that's going to be your exit ticket for today. Once you're done with that, you're welcome to work on your section 2 notes, which are your homework tonight. Okay? Nope, but it is the one on math. It's the math. Me? Oh. She doesn't count? Is that what we're saying? Sorry, I forgot to ask. Are you good?
Yeah.
Okay. Yep, do it on a separate sheet of paper. It's going to be the thing you submit for your exit ticket. Think about what type each one is as well. Hmm?
You want us to write what type it is or no?
No, I just want you to think about them while you're doing them. You can do this. Ooh.
Do we need to write the enders too?
Yes, please. Yes. Stop there.